What's good, you guys? I'm back with another reaction video. Don't mind me, I just woke up, yo. I'm really disturbed by this title. To the person that sent me this on Instagram, what were you thinking? What were you thinking when you sent me this? This kid is about to turn his own pee into an artificial sweetener. This is some weird, scary, freaky shit. What were you thinking when you sent me this, yo? I wonder, now I'm really curious if this actually gonna work now, actually. Cause what the fuck? Let's get right into the video, yo.
In the last video, I isolated some urea from my own urine, and now I'll be using it to make dulcin. Dulcin was one of the first artificial sweeteners, and it's about 250 times sweeter than regular sugar. It was first discovered in 1884, but it never became very popular because it was overshadowed by another artificial sweetener called saccharin. This is probably a good thing though, considering that dulcin was eventually taken off the market in the mid-1900s due to health concerns. Saccharin has had its ups and downs, but it's still around and is generally deemed safe. What I think's interesting is that the structure of dulcin is very close to Tylenol, which is what I'll be using to make it. With just a few chemical alterations, I can make it go from being gross and bitter to pleasantly sweet. This is the overall process that I'll be doing, and it has two major steps.
Science is crazy.
First, the Tylenol's converted into phenacetin, and then it's reacted with urea to make dulcin. Because this is an edible chem video, at the end I'll be tasting the dulcin that I make. Keep in mind though that I'm doing this at my own risk, and tasting chemicals is generally a bad idea. In terms of ingredients, this is everything that I'll be using. The drain cleaner, acid, high-proof alcohol, Tylenol, and baking soda were all purchased locally. For the urea, I'll be using a combination of the stuff that I got from my own pee and from cold packs. I'll explain later on exactly why I didn't just use purely my own. The last ingredient is ethyl iodide, which is the hardest to get. I ended up making it myself using almost the same process as my methyl iodide video. Before getting started with the main procedure, I first need to make a basic ethanol solution. To do this, I add about 190 ml of the ethanol to a beaker, dump in 7.4 grams of the sodium hydroxide drain cleaner, and turn on the stirring. To limit the amount of ethanol that evaporates off, I also cover the top with some plastic wrap. Unfortunately, this is going to take quite a long time to dissolve, so I need to leave it overnight. By morning, all of the solid pellets had disappeared, but it was still quite cloudy. This is fine though, and for now, it's temporarily placed on the side. Okay, so now to get started on the main reaction. I need to powderize 25 pills of Tylenol, which I do by just putting them in a coffee grinder. It's also possible to just crush them using a hammer or something, but I find this is the easiest way. The powder is then added to a large round-bottom flask, followed by the ethanol solution that I made earlier. I do my best to wash the funnel, and I also dump in the stir bar from the beaker. The funnel's taken away, and I set up a stir plate as well as a heating mantle. I also set up a condenser column with cold water running through it. Then I turn on the stirring and the heating, and I wait for it to get to a boil. As it warms up, it slowly changes to a dark red color, which I think is just due to some side reaction. When it eventually starts boiling, I turn on my timer and I wait 20 minutes. What I'm doing here is an acid-base reaction between the Tylenol and the sodium hydroxide drain cleaner. This generates the sodium salt of Tylenol, which has a more reactive oxygen group and is important for the next step.
Shit is crazy.
20 minutes later, I take the heating mantle away and I let the reaction cool down a bit. Then, when it's no longer refluxing, I quickly pour in 25 milliliters of ethyl iodide. Now, I need to put back the heating mantle, but I have to be careful because it's still really hot. The ethyl iodide has a really low boiling point, and it tends to go crazy with the extra heat. For this reason, it's important to use ice water in the condenser, otherwise it'll be overloaded and ethyl iodide will escape out the top. Anyway, this is now allowed to reflux for another 20 minutes. The reaction that's going on is between the sodium salt of Tylenol that I just made and the ethyl iodide to make phenacetin and sodium iodide as a side product. The new bond that forms is highlighted in red, and it's known as an ether. This method of forming ethers is commonly used in organic chemistry, and it's known as the Williamson ether synthesis. After 20 minutes, the heating mantle is taken away. Then, I let it cool to the point where it's no longer refluxing, and I take away the condenser. Because I use Tylenol pills directly, there's a whole bunch of pill filler mixed in here, which needs to be filtered off. When this is done, I'm left with a nice and clear solution, and I move on to separating out the phenacetin. It's really not soluble in water, so I just need to dump it in some, and it immediately crashes out. The initial precipitate was quite fine, but after a couple minutes, some larger clumps start to form. To make sure that I knock out as much phenacetin as possible, I cover the top with some plastic wrap, and I put it in the freezer. I take it out a few hours later, and quite a bit of solid has settled at the bottom. This is all added to my vacuum filter, and the liquid's pulled away. Then the beaker and everything in the filter is washed with some water. When I'm all done, I'm left with some crude phenacetin, which I'll have to clean up. To do this, I transfer it all to a beaker, and I recrystallize it using a combination of water and ethanol. It is possible to only use water, but it would take quite a bit. The ethanol is added to slightly increase the solubility, so I can use a smaller volume. I ended up using a lot more than I expected though, so I had to transfer everything to a larger beaker. I continued adding more water, but the solution didn't really seem to clear up. So I took it off the hot plate, let it cool a bit, and then put it in the freezer. This isn't going to be the best recrystallization I've ever done, but it should still be good enough. Fast forward a few hours, and a bunch of nice and white solid has formed. Again, I filter it all off and wash it with some ice-cold water. Then I leave the pump on for about 15 minutes to dry things up as much as possible. It's all transferred to a piece of paper, and I let it dry for about a day. So a day later, I'm left with about 11 grams of nice and fluffy phenacetin. The yield here is honestly pretty bad, but it's still way more than I'm going to need.
Arkansas homeowners, would you like to erase your electric bill for free this year? You can with a brand new state clean energy program that gets you solar panels with
I don't see any P.
To make the Dulcin, I'll be doing it on a smaller scale, and I start by adding 5 grams of the phenacetin. Then on top of this, I pour in about 25 mils of dilute hydrochloric acid. Then I set up a heating mantle and a condenser column, and I reflux it for about 15 minutes. Under these hot and acidic conditions, the amide bond in the phenacetin is going to be hydrolyzed. This produces paraphenetidine and acetic acid. The paraphenetidine then reacts further with hydrochloric acid to form paraphenetidine hydrochloride, which is water-soluble. After 15 minutes, I turn down the heating mantle, let it cool a bit, and take away the condenser. Then I slowly and carefully start adding solid sodium bicarbonate, which quickly reacts with leftover hydrochloric acid. This reaction produces sodium chloride, water, and carbon dioxide gas, which leads to a lot of bubbling. The goal here is to neutralize most of the acid, but not all of it. Initially, it's extremely acidic at a pH of around 1, but it needs to be brought to a slightly acidic pH of around 6 to 6.5. In this range, the phenetidine hydrochloride is converted to its free base form, which is much more reactive. So the basic process here is to add small amounts of baking soda, mix it until it completely reacts, and then to test the pH. The testing's done using some cheap, universal pH papers, which unfortunately aren't super accurate. I eventually get to what I think is the correct pH range, and the solution has darkened quite a bit. This is due to the formation of the free base phenetidine, and when I turn off the stirring, you can see it all float to the top. I replace the funnel with a clean one, and then I add 6.7 grams of urea. However, it's only 50% urea that I got from my own pee, and the other half came from cold packs. The reason I did it like this is because this reaction isn't super efficient urea-wise, and a huge excess is required. So I could have just used purely my own, but I felt that it would kind of be a waste. At the end though, 50% of the product will still be coming from my own urea. Anyway, when I'm done with the urea, I take away the funnel and I add 20 drops of pure acetic acid. Then I increase the heating, add a condenser, and reflux it for about an hour. I couldn't find any super reliable sources, but this seems to be the reaction that's going on. Under these hot and acidic conditions, urea is in equilibrium with another molecule called cyanic acid. As the cyanic acid forms, it quickly gets attacked by the paraphenetidine and leads to the formation of dulcin. Initially, it doesn't look like too much is happening because all the dulcin stays dissolved in solution. After about 10 or 15 minutes though, the concentration of it gets high enough and it starts precipitating out. As I said before, I let this reaction go for about an hour and then I take away the heating mantle. I let it cool to room temperature and then I put it in the freezer overnight. Times with ice cold water, and I leave the pump on to dry them up as much as possible. The dulcin that I have at this point is probably quite pure, but just to be sure, I recrystallize it again. Then I filtered it off, dried it in an oven, and this is the final product. It's 2.2 grams of relatively pure dulcin, which represents a percent yield of about 44%. A procedure that I found online claimed the average yield was between 30 and 50%, so this is quite good. To test for purity and to see if this actually is dulcin, I did a quick melting point test and it was pretty close to the theoretical. Anyway, now for the important part, which is the taste test. Before I do it though, I do need to say that it's generally a bad idea to taste or eat anything that you make in the lab. I take a lot of precautions to make sure that it's as safe as possible, but I'm still doing it at my own risk. Okay, so here's the dulcin that I made, and I'm just gonna go ahead and try it. So, add a little bit to a spoon. Not too much though, because I mean, it's not exactly healthy. Okay, that's too much. Okay. It's gonna be very hard for you to see from there, but there's not very much here. It's probably 10 milligrams or something. Okay, so okay, so it's definitely very sweet, but the first thing that really stands out to me is that because it's not very water soluble, it doesn't dissolve very well in your mouth, so it's not very pleasant, even though it's sweet. The texture is kind of gross, I guess. And the one thing that is good about it, though, is that it has no bitter or weird aftertaste. Most other artificial sweeteners, like aspartame, even saccharin that was competing with at the time, they all have bitter or weird aftertastes, but this just tastes like plain sugar. So I can see why it became popular at the time, but I'm surprised, honestly, that it didn't take off, considering that, in my opinion, it's a lot better than saccharin, or sweet and low, as we call it today. Just as a comparison, I have some sugar here, and I'm just going to take a small amount. The dulcin honestly tastes pretty similar, but they both have their very unique flavors. I could tell this is sugar, and I could tell this was dulcin if I ate it, but probably if it was mixed into something I wouldn't be able to. The other thing I can't tell with just this is how much sweeter the Dulcin actually is. I said in the intro it was 250 times sweeter, but there's no way to tell by just tasting it like this. It needs to be dissolved into a solution. Basically, a certain amount of sugar is dissolved into solution, and then you keep dissolving Dulcin to get to the equal sweetness level, and it takes apparently 250 times less Dulcin to do this. You can't really do it in cold drinks because it's not very soluble, but I'm going to try it out with some hot drinks, and I'm going to be making some tea. So, what I have here are two little beaker mugs, and I'll be making some tea. I'm just going to get the sugar and the water. I'll be back in a second. Okay, so in the beaker on the right, I'm just going to dump the sugar in. So it's a teaspoon. Now I will fill both with, I guess, 300 mils of water. And now, this isn't going to be super scientific. I don't have a scale. I don't have any real way of quantifying the Dulcin that I add. But if it's supposed to be 250 times sweeter, I should be able to add a 250th of this teaspoon, and then these two should taste like they have equal sweetness. So I will try that out. The one problem too is that my sugar is granulated, and this is super fluffy crystals, but whatever. Okay. That is way more than a 250th. Okay, so again, you can't really see it, but I've lined the bottom. I don't know if this is 250th, but it's definitely way less than a teaspoon, so we'll try it out. Add it to the tea. The one annoying thing about Dulcin I find is that it really, even in hot water, it kind of resists dissolving. So you've to stir it around for a little bit to get everything to disappear. So, in theory, these should be about equal sweetness now. So I will give it a try. I will taste the sugar one. Okay. Now I will taste the Dulcin one. Actually, the Dulcin one is considerably sweeter. So, this is a completely unscientific test. I have no weights, nothing, but I put very little Dulcin in, and it's considerably sweeter than this one. The one thing that is interesting to me is that I can no longer taste the difference between them. So before I could taste the difference between the Dulcin and the sugar when I had them plain, but between these two teas, if I gave you, or if someone gave me a cup of either of these, I wouldn't be able to tell the difference. Honestly, it tastes pretty good. Yeah, so that's about it. As usual, a big thanks goes out to all my supporters on Patreon.
This was weird, but it was educational. I gotta give it that. If y'all like, comment down below what y'all think. If y'all like the video, hit the like button, subscribe, join the gang, y'all. Let's get to 1,000 subscribers. I'm gonna put my Instagram in the description down below. You guys can go follow me there, send me some more videos to react on. I got y'all. And I'm gonna get up out of here, cause I'm weirded out now. But peace.